All right, continuing on with errors, I believe we're going on to 9.2, which should be recoverable errors with result. And let me just maximize this for now. All right, recoverable errors with result. Most errors aren't serious enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you try to open a file and the operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. Recall from handling potential failures with the result type in chapter 2 that the result enum is defined as having two variants, OK and error. So we have the result enum, here we go, result. We have OK and error as the two types. The T and E are generic type parameters. We'll discuss generics in more detail in chapter 10. What you need to know right now is that T represents the type of value that will be returned in a success case within the OK variant, and E represents the type of error that will be returned in the failure case within the error variant. Because result has these generic type parameters, we can use the result type and the functions that the standard library has defined on it in many different situations where the successful value and error value we want to return may differ. Let's call a function that returns a result value because the function could fail. And they have an example down here. Hello.text. So let's try that out. Open my editor. See what they have here. We import our file from standard library. So use standard library file system file. All right, and then we say let f equal file dot, I guess it's not necessarily a dot, but file open. And we pass in the path of hello.text. And as you can see here in the editor, we have the result that gets returned, and it is a file or an error. How do we know that file open returned a result? We could look at the standard library API documentation, or we could ask the compiler. I guess in terms of the editor situation here, the editor may have asked the compiler, and this is just showing it to us so we can see that, but they don't know that. If we give f a type annotation that we know is not the return type of the function and then try to compile the code, the compiler will tell us that the types don't match. The error message will then tell us what the type of f is. So let's try it. We know that the return type of a file open isn't U32. So let's change the let f statement to this. Basically what we're doing here is trying to figure out the type of f, right? We can assume that our editor didn't tell us. We can assume that we did not know. And if we had to try to discover it, the route that they're suggesting is set the type of f to something we know is invalid, and then ask the compiler by trying to compile the code. So seemingly, if we do cargo run, we don't need a backtrace. We're going to get an error that's going to tell us the type. See, expected U32 is what we put here. And then what we found is this over here. Let me see if I can scroll over. Oh, it folded over here. Okay, what we found is a result type with a file and an error. So this is the type, which we knew, but that's one way of going about finding it. So continuing onward, attempting to compile this will give us the following output, which we saw. And right here is where they give us an information. So this tells us that the return type of the file open function is result TE. The generic parameter T has been filled in here with the type of success value, which is the standard file system file, which is the file handle, and the type of E used in the error value is standard IO error. This return type means that the call to file open might succeed and return a file handle that we can read from or write to. The function call also might fail. For example, the file might not exist, or we might not have permissions to access the file. The file open function needs to have a way to tell us whether it succeeded or failed, and at the same time give us either the file handle or error information. This information is exactly what the result enum conveys. So what we're saying here is that we have the file open has some different variants I can go through just in terms of what the result is, right? We can try to open the file and it can return the file and we can write to it and read from it. That's a possibility. Another possibility is, let's say the file doesn't exist. So then file open needs to be able to return an error, which the enum allows because it has an error option. And then they went through another possible error case, which was you can open the file, but you're not allowed to write to it. Theoretically, I think that error might be further down the line when you actually try to write to it, but opening should be fine, given that you have file permissions. Oh, actually, no, I read that wrong. We might not have permission to access the file. So another example is that the file could exist, but we don't have access to open it. That's when we try to open it, file open should return us an error, and the error should convey what the issue was. And we can do all that with the result enum. So in the case where file open succeeds, the value in the variable f will be an instance of OK that contains a file handle. In the case where it fails, the value in f will be an instance of error that contains more information about the kind of error that happened. So they gave us the options. If it succeeds, file will return an OK within it. Or sorry, the result enum will have an OK within it, which will have the file handle. And if it fails, the result enum will have an error, which will then have some sort of message in it that will tell us what actually happened. We need to add to the code in listing 9-3 to take different actions depending on the value file open returns. Listing 9-4 shows one way to handle the result using a basic tool, the match expression, that we discussed in chapter 6. So one way to doing is using match, which will force us to iterate over all of the possible values that f could have, or file open. And we can say let f equal match f, and then have OK. And if it's OK, have file in here. And then have the code that we want to do, run, file. They're not doing anything with the file. And in case of error, pass in the error here. Have our little code block, and then we can just panic. And we can say something like, there was a problem opening the file. And then we can put the debug information for the error. That seems to work. They did error dot what? They just passed an error. They just passed an error. I guess they don't need that. Oh, because it's return value, right? And down here, put a semicolon, and we can run this. And I do not have a hello.txt file, so we should expect an error, or at least a panic. And this was not written correctly. OK is capitalized. My bad. So the program finished. We have a panic. We have a backtrace if you want to see everything unwrap. And what is the error message? Not found message. No such file or directory, which is true. There was a problem opening the file, which is I wrote there. And then we have the debug stuff for the error, which starts from, I guess here, OS, so it's an OS error, code 2, okay, kind of error, not found, message, no such file or directory. So that's pretty explicit. Note that, like the option enum, the result enum and its variants have been brought into scope by the prelude, so we don't need to specify result : before the OK and error variants in the match arms. What they're saying here is that in the prelude, which is, I guess, imported by default, OK and error, these variants of result have been imported, so we can just reference them directly, which we did here. Here, we tell Rust that when the result is OK, return the inner file value out of the OK variant, and we then assign that file handle value to the variable f. So that happened here. We have the OK variant, we have the file, we're just returning the file, and that's going to be set to f, which is file. You can see right there. After the match, we can use the file handle for reading or writing. Now we go to the other arms. The other arm of the match handles the case where we get an error value from the file : open. In this example, we've chosen to call the panic macro. If there is no file named hello text in our current directory and we run this code, you'll see the following output. And that's what we saw earlier, with the exception of we have a kind. They just have an error code. A kind not found. Yeah, I don't see kind. And as usual, this output tells us exactly what has gone wrong. So, matching on different errors. The code in listing 9-4 will panic no matter why file open failed. What we want to do instead is to take different actions for different failure reasons. If file open failed because the file doesn't exist, we want to create the file and return the handle to the new file. If file open failed for any other reason, for example, because we didn't have permissions to open the file, we still want the code to panic in the same way as we did in listing 9-4. So let's look at listing 9-5, which adds an inner match expression. Basically what they're saying here is that there are different reasons for why this code could fail, or at least for opening files. And based on those reasons, we may want to handle those errors differently. They brought up the example if the file doesn't exist. If the file doesn't exist, we can just create it and then return the handle to the new file. That's how we can handle that situation. In any other situation, which they brought up an example, but any other situation, we can just panic like we're doing currently. So that's what we do down here in listing 9-5. And what they do, let's look at this real quick. They have an error, so the error is still here for the original match. And then this goes into another match. So this is sort of nested matches. That's fine. So let's take this out. So we have another match. We have an error dot kind, which is what we saw down here, kind. We call that, and then we have a match on top of that. Now, if the error dot kind equals not found, file create hello text. And then in the create looks like it can return an error. So it has an OK, this is file created, an error, try to create the file, but there was an error. And then other errors, panic. Does that compile? I'm not sure if that compiles. I don't know if this covers all the other error types or the other variants of kind. But we can try it. So kind, go right here. We have error kind colon. Looks like we have to import that because that's not in the prelude. So use standard library io dot colon dot error kind, have that there. And not found right there. So if it is not found, do another match. File colon create hello.text. And then we have to check to see if this is okay. If it is, just return it. of C, and if it is not, panic. And what message they have here? Try to create file, but there was a problem. Put the debug information of the error. Go back out here. So that match is done. This error kind looks like it's been completed, and now they have other errors. I don't know what that refers to. That's the part I'm really confused about. I don't know if that does something. Huh. Looks like it actually might work. Panic. There was a problem. The message the same? Problem opening the file, yeah. Opening the file. Other error. Comma. And let's see if that compiles. No, I have an issue somewhere. All right, let's figure out what this issue is unexpected token. Expected one of these. Line. I didn't do it here. And looks like it compiled just fine. So other error. Wow, that's something that's kind of magical. Basically, from what I can see, given that it compiled, we know about the rules of match. Match states that we have to deal with all other, we have to deal with all variants of the kinds that can exist. And this seemingly did that. So for all other errors, this happens. The type of the value that file open returns inside of the error variant is IO error, which is a struct provided by the standard library. This struct has a method kind that we can call to get an IO error kind value. The enum IO error kind is provided by the standard library and has variants representing the different kinds of errors that might result from an IO operation. The variant we want to use is not found, error kind : not found, which indicates that the file we're trying to open doesn't exist yet. So we match on F, but we also use an inner match on error.kind. The condition we want to check in the inner match is whether the value returned by error.kind is the not found variant of the error kind, enum. If it is, we try to create the file with file create. However, because file create could also fail, we need a second arm in the inner match expression. When the file can't be created, a different error message is printed. The second arm of the outer match stays the same, so the program panics on any error outside of the missing file. So they just re-explained what was going on here. Just one more time, just for clarity's sake. We have a match on F, which is this. It's a result. It has a file or an error. If it is a file, we say, okay, return that file. If it is not, if it is an error, we need to check the type of error it could be. So then we have an inner match. This inner match checks to see if the type of error is not found. If it is not found, we then do another inner match and try to do a file create. So the file create operation is going to return something, and we check to see if that return value is okay or an error. If it is okay, we return that file, and that's what eventually gets returned here to this F. If not, we return an IO panic, which is another IO operation, file create, and we return that panic, and that's fine. It can be an error. Oh, sorry, the panic isn't returned. It's called explicitly, and that will end the program. If an error exists and that error is not found, if it's a different error, then we go to this arm, which does the same thing as we were doing before, just a panic. That's a lot of match. The match expression is very useful, but also very much a primitive. In chapter 13, you'll learn about closures. The result enum. In chapter 13, you'll learn about closures. The result type has many methods that accept a closure and are implemented using match expressions. Using those methods will make your code more concise. A more seasoned Rust programmer might write this code instead. So let's see what they have down here, right? We have file open, hello text. We have an unwrap or else, and it looks like in the case of else, there's an error here that gets passed in. And then if this error.kind is equal to error.found, we do this. We do a create, and then we unwrap that as well. If there's an error there, then we use that same panic right there. But if the error wasn't of type not found, we come down to this else and we do for everything else. Which I believe we did learn about this in the match expression in the very last one. We did the if else. So let's write that. This is the same code that we already had. However, I think we currently have an extra file. We ran this once, so we have a hello text. Let's remove this hello text. Hello text is now gone. Cool. So I'll make this a little bit smaller, and let's start writing this. So we can just erase all of this, right? So they did all the way up here. They did an unwrap or else. So when we type unwrap, or at least un in our editor, we see we have unwrap, unwrap error, unwrap or else. I don't know explicitly what all of these do. However, it seems, just based on reading it, that this or else that they're using is if there is an error, you pass in a closure, which they're going to explain in chapter 13, but seemingly the value of what was seemingly the value that was the error is going to be passed in right here. So we can type that here, error, and then what we want to do with that error comes next. So after this error, we have to check to see the kind of error it is, and that's where the if statement comes in. So if error.kind is equal to error kind, check this enum, we go down to different types, not found, do stuff. This is where the file create comes in. Create hello.text, but this could also fail, so we have to wrap it. And in here we do the panic. Try to create the file, but there was a problem. Give it debug information. Pass in the error. Down here we can write the else. For all other types of errors that are not of error kind, panic, and give it the generic message. There was a problem opening the file. Debug information. Pass in error again. Oh, well, I mean, this is different closure for error, so different value of error. And let's see if I wrote that correctly. Think so. Let's see if it compiles. Well, let's run it. this got imported. Do not want to use that. Run it real quick. And it looks like it ran successfully. And to show that it ran successfully, we have a hello text, which is the file I deleted. Alright, so they didn't explain what a closure is, and I'm not going to do it to chapter 13. However, I can seemingly do it with a glossy overview. So a closure is an encapsulation of a code block, right? What they do is they have this value of else, which is going to be the error. We labeled it here. We could have named it anything essentially. But this seemingly denotes that we're going to use this value in this next code block. And in let's look at this in our editor. So this value in the next code block. This code block goes from here to here, right? So here we use that value, error.kind, and we check to see the error type, error not found. And now here in another code block, we do file create, and this could also fail. So we create another closure. So this closure is going to act on this error, which is going to be associated with this failure, not this one. And we do the same thing. We take this value and print it out here. We leave this code block, or this closure, and come out of it, and we have another one. Oh, not another closure, but the existing one. This guy. So you see when I highlighted this error, this one highlighted as well, denoting that I'm using this error here and here. But I'm not using it here. That error is associated with this error, which is another closure, or closure within a closure. Different code blocks, encapsulation, however you want to describe it. But yeah, that's what's going on. So let's go back to our code. Although this code has the same behavior as listing 9-5, it doesn't contain any match expressions and is cleaner to read. Come back to this example after you have read chapter 13 and you look up the unwrap or else method in the standard library documentation. Many more of these methods can clean up huge nested match expressions when you're dealing with errors. They didn't explain any of that. They just said come back after you read chapter 13, which is seemingly going to explain the closures, probably in greater detail and more accurately than I just did. And they said you can also look up the documentation for unwrap or else. I mean, it's probably pretty explicit there as well. So the next section, shortcuts for panic on error, unwrap and expect. Using match works well enough, but it can be a bit verbose and doesn't always communicate intent well. The result type has many helper methods defined on it to do various tasks. One of those methods, called unwrap, is a shortcut method that is implemented just like the match expression we wrote in listing 9-4. If the result value is the OK variant, unwrap will return the value inside the OK. If the result is the error variant, unwrap will call the panic macro for us. Here's an example of unwrap in action. So they're saying that we could have done this instead of what we did in listing 9-4. And let's go up to 9-4 real quick so we can look at it. That's 5. Instead of doing this. This is a lot of writing. We could have just wrote dot unwrap and called it a day. Well, I mean, wait, was it a dot? Yeah, dot unwrap. No, that's unwrap or else. Here we go. We could have done this, dot unwrap and called it a day. And we've saved ourselves like 4 lines of code. So if we run this code without a hello.txt file, we'll see the following error. I believe them, but for parity's sake, we can just write it. Yeah. Stop right there. Unwrap. Call it. And let's remove the hello text and run this again. And we have our panic. No such file. Kind, not found, which is what we were expecting. Another method, expect, which is similar to unwrap, lets us also choose the panic error message. Using expect instead of unwrap and providing good error messages can convey your intent and make tracking down the source of the panic easier. So what they're saying here is that expect this is the same thing, however, allows you to pass in a message. And the reason why this message is important is because this message can be unique for your code and is something that you can reference in terms of finding out where the error happened. So let's say we had a program that did a bunch of different file openings in a bunch of different files. Like you had like a file here, file here, file here. If you want to figure out where this error was coming from explicitly, you could possibly give them unique messages and thus, using the message returned in the panic, find out which line of code it was actually referencing. But in theory, if it is your code that is panicking, it should give you the line reference, and that should be fine as well. This is more about style and technique. So let's do the expect. Pass it a message. They said fail to open file. Fail to open hello.txt. Which is nice. We have context now. We know what file that we failed to open. Try to run this again. The message now tells us what we were trying to do at the time of panic. We failed to open this file. And that's something that's good for debugging purposes because now we know what the code was doing at the time. It was before, I don't think it gave us a file. Before, I think it just said stuff. We use expect in the same way we use unwrap to return the file handle or call the panic macro. The error message used by expect in its call to panic will be the parameter we pass to expect rather than the default panic message that unwrap uses. Here's what it looks like. You have an example down here. You have one here. Ooh, wait, hold on. Do we already have a file? Let me just make sure. No, we don't. So that was fine. Cool. Because this error message starts with the text we specified, fail to open hello.txt, it will be easier to find where in the code this error message is coming from. If we use unwrap in multiple places, it can take more time to figure out exactly which unwrap is causing the panic because all unwrap calls the panic print the same message. What they're basically saying here is what I said earlier. If we're using multiple unwraps and they can all return the same error message, then while we're debugging, we don't know exactly which one of these errored out. Whereas if we use expect and pass in a unique message, it'll be easier to parse out our code and figure out where that error is coming from.